Hello everyone and welcome back to Paideia Classes. Today we are continuing our journey through the fascinating worlds of sets. In our previous videos, we have explored the concept of sets. We have learned about well-defined collection and understood the different forms of representing the sets. Now, it's time to put that knowledge into practice. In this session, we'll be solving the example and exercise 1.1 from chapter 1 of your NCERT Class 11 book. These problems are designed to reinforce the concept we have covered, so make sure to follow along and try solving them with me. So let's start with our first example. Write the solution set of the equation x square plus x minus 2 is equal to 0 in roster form. So, you already know how to solve this equation. X square plus x minus 2 is equal to 0. Try to pause the video and solve the equation. We will be solving this by factorization. We can write this x as 2x minus x. And when we solve, we'll get x plus 2, x minus 1 is equal to 0. So on solving this, we'll get x is equal to minus 1 and x is equal to plus 1 and x is equal to minus 2. So the solution set of this equation is 1 and minus 2 in roster form. I hope this is clear. It was a very simple example. Let's move to this example. Write the set x such that x is a positive integer and x square is less than 40 in the roster form or tabular. So x is a positive integer. It means x belongs to 1, 2, 3, 4 and so on, right? Positive integer ho or natural number, both are same thing. And x square should be less than 40. So 1 square is 1. So this 1 would be in the set. 2 square is 4. So this 2 would be in the set. 3 square is 9. So 3 will be in the set. 4 square is equal to 16. So 4 will be in the set. 5 square is 25. So 5 will also be in the set. 6 square is 36. So 6 will be in the set. And 7 square is 49. Now this is greater than 40. And for all the other positive integers, the square would always be greater than 40. So we'll stop at 6. So to write this in the roster form, we'll write it in curly brackets. So this will be your required set. Let's see the next example. Write the set A is equal to 1, 4, 9, 16, 25 in set builder form. Now, to write in the set builder form, we need to see what a common characteristic. We need to find a common characteristic that all the members of the set satisfy. So can you find that characteristic? 1, 4, 9. I hope by seeing these numbers, you are getting this idea. 1 square is 1, 2 square is 4, 3 square is 9, and then 4 square, 5 square. So 1 square, 2 square, 3 square, 4 square, 5 square, and so on. So to write it in the set builder form, how will we write it? We'll write it A is equal to x such that x is a, so 1, 2, 3, 4, 5. Natural number x is the square of a natural number, right? Because if you see carefully, what are the elements of the sets? 1 square, 2 square, 3 square, 4 square, 5 square. So 1, 2, 3, 4, 5. These are natural numbers, right? So a is equal to x such that x is the square of a natural number. Or you can also write it like a is equal to x such that x is equal to n square, where n belongs to natural number. So here also x is equal to n square. So n is belongs to natural number, means n is 1, 2, 3, 4, 5. So x is 1 square, 2 square, 3 square, 4 square, 5 square. So this is how you will write this set in set builder form. And why do we need this alternative method? You will see in the next example. Now let's see this example. We have given a set 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6 and 6 by 7. If you look carefully and you want to find a common characteristic in all these members, you can see that the numerator is 1 less than the denominator. So 1 is 1 and 2. So it is 1 less than the denominator. Then 2 and 3, again 1 less than the denominator. So whatever you have in the numerator, the denominator is what? Plus 1 to that, right? So what are these? The number is written in the form of n divided by n plus 1, where your n is what? 1, 2, 3, 4, 5 and 6, not more than that. So you cannot write n belongs to natural number, right? So let's try to write this in the Brewster form. So we can write it as x such that x is equal to n divided by n plus 1, where n belongs to natural number and the value of n is from 1 to 6, right? So if you write it like this, you have all the properties. X is written in the form of n by n plus 1. N is a natural number and the value of n is 1, 2, 3, 4, 5 and 6. So now you cannot write this set in the form of this. X is the square of a natural number. It is not very clear here. So this is why we use this type of thing to write it. I hope it is clear. Now let's see the last example of this exercise. Match. Okay, just a second. We have this example. Now let's solve these sets in the set builder form first, and then we'll match it with the sets on the left side. So x is a positive integer. Again, it means that x is from 1, 2, 3, 4 and so on. And is a divisor of 18. So what are the divisor of 18 that are also positive integers? 1 divides 18, 2 divides 18, 3 divides 18, 4 does not divide 18, 5 does not divide 18, 6 divides 18, then 7 does not divide 18, 8 does not divide 18, 9 divides 18, and then finally 18 divides 18. So if you look carefully, this is your third option, right? So you can match it like this. Now, x such that x is an integer. So what does integer mean? It is plus minus 1, 0, plus minus 1, plus minus 2, and so on. So, and x square minus 9 is equal to 0. If you solve this x square minus 9 is equal to 0, you will get x square is equal to 9. And on taking square root, you will get x is plus minus square root of 9. And you will get x is equal to plus minus 3. So the solution is 3 and minus 3. So here this set is what? 3 and minus 3. So this is your fourth option, right? Now, x such that x is an integer and x plus 1 is equal to 1. So again, x should be from this set, and on solving this x plus 1 is equal to 1, we'll take the 1 over this side. So x would be 1 minus 1 or 0. So x is 0. This is the only solution. So this is what? This set is what? X is equal to 0, which is your second answer. And finally, x such that x is the letter of the word principal. So if you want to write it, we have P, we have R, we have I, we have N, we have C, then we have I, but we have already wrote down I, and we should not repeat the set. The element of the set should be distinct. So we'll not write I again, and same goes for P also. And then we have A, and then we have finally L. So this is your first option. This is your first option. So this means this last is this last arrow goes to first. Okay. So I hope it is clear. Your first is matches to D. Your second matches to fourth. Your second matches to option C. Your third set matches to option A. And finally, your fourth set matches to option B. So we'll conclude the examples of chapter 1 before the exercise 1.1 over here. If you have any doubts regarding anything, please ask in the comment section. And in the next video, we'll solve the question of exercise 1.1. Hope you like the video. Thank you for watching.